We're going to learn how to design primers. So the first step is, first you go on NCBI, you type the name of your gene, and then you get the entire sequence. Copy the sequence and paste it on any software of your choice. Right now I'm using the software called ape. This was the gene. I had copy pasted the entire sequence on WordPad, and then you just paste it over here on this app called ape. Okay, so the sequence length of this gene is 3810 base pairs. So you're going to go at the C-terminus end, and you're going to select around 500 to 700, anywhere between these this range of sequences at the C-terminus end. So I've taken around 650 sequences at this end. And then you go over here on tools, okay? Like you can see over here, the tools option over here. So you go on tools and you select find primers, and then this dialog box will pop up. So you have some factors that you could take into consideration, like the length. So the length which I go with is anywhere between 18 to 25 base pairs. The TM value depends between 55 to 70, but you have just taken like the temperature, chosen the minimum temperature to be 55 and the maximum to be 65 degrees Celsius, and then going with the GC content. So your minimum GC content can be anywhere between 50 to 60. And then, okay, so I've not changed the GC clamp and the orientation, everything seems fine. So you click on OK once you've done that. So now you've got like different set of primers, as you can see over here. And now for instance, I want to choose this. Okay, it's gonna highlight that set of region, that portion of the sequence. So here you go, you right click and then you press on new feature, and then you choose a color of your choice. I will choose this one, say OK, and this region is completely highlighted now. Okay, you have this sequence now which you have highlighted. Copy that highlighted sequence, only the highlighted sequence, right click, copy it, go on file now and select the option new. You gotta paste it here and then go on edit and say reverse complement. So it's gonna give you a reverse complement of that sequence that was highlighted over there in blue. It ends with a C, right? So this is good to go because we always want the 3' end to end with a G or a C. And now why are we taking the reverse complement of it is because we want the orientation to be such that the nucleotides are always added in the 5' to the 3' end, right? Go again here at this drop down that was earlier reflected, and you go downward somewhere, anywhere down. Now it's very important to know this one thing, to keep this one thing in mind, that the difference in the TM value of the two primers, that is the forward and the reverse primer, should not be more than 5 degrees Celsius. Okay, it's very important because an average of these two will actually decide your annealing temperature. So the annealing temperature should be close or in close proximity to both your reverse and forward primers. So that is the reason why we always take into consideration that the TM value for both your forward and the reverse primer should not be anything more than 5 degrees Celsius. Okay, and then you take another one. Okay, maybe this one. This could be a forward sequence. Oh no, it cannot, because see, here you can see the forward sequence starting from the 5' to the 3' end is ending with T, and we always need to make sure that the 3' end ends with a G or a C. So no, we cannot pick this primer as a forward primer. Let's choose another one. So yeah, we could go for this, I guess, or maybe this. So here it is. It's clearly ending with a C. So we can highlight this region again, go on new feature, select a different color maybe this time and say okay. And this is your forward primer. All right. Now, the next thing that you got to do is see the amplicon size. I mean, the number of base pairs that you've taken. So the length is 198 base pairs, right? From your forward to your reverse sequence. 3' end. Your 5' end to the 3' end of this whole thing is the length of your amplicon, which is 198 base pairs. So it's fine. Anything between 150 to 200 base pairs will do its job without any problem, hopefully. So then you can copy, you can like paste the forward primer sequence on your Word file, and the reverse primer is going to be the reverse complement of this sequence in the squid blue region. The reverse complement of this, like we had discussed earlier, like here, is going to be a reverse primer. Okay, so you paste it on a Word file, and then you can use different soft tools, like for example the oligo analysis tool, and that tool is actually going to help you see if there's any dimer formation taking place or not. So if there's no dimer formation taking place, you can go ahead and order those primers.